Okay, so we're asked to conduct an ANOVA analysis. A consumer's testing group is comparing the average lifetime for three brands of batteries. So it sounds like a good setup for ANOVA. We can compare three different means. The batteries are being tested, and flashlight determine length of time in hours. Consumer test group collects random data. Consumer test group is interested to know if the average battery lifetimes are statistically the same for the three brands. We're supposed to use a significance level of 5%. So, which is the correct null and alternative hypotheses? Remember that if you haven't seen it before, for ANOVA, the null hypothesis is that all the means are equal. Okay? The alternative is that at least one of the means is different from the others. Okay? The alternative just tells us that there's some sort of statistical difference. Can't give us any more information than that. Can't say they're all different from one another. Can't say just a couple of them are really different from one another. So our alternative hypothesis is that at least one mean is different. All right, so now we got our null and alternative hypothesis. We're supposed to calculate the test statistic and the p-value. So I'm going to go to Google Sheets. This is the first time I've actually done this. So I haven't done an ANOVA in Google Sheets. I've done it in Excel, but everything you have to do, you have to download some sort of add-on package. Another suggestion would be if you don't want to try to do these steps, I'll try to do them as quickly as possible, but you could Google search an ANOVA calculator. Those usually let you just type in the data. But we need an add-on, okay? So let me show those steps again. Click Add-ons in Google Sheets. Click Get Add-ons. Click the Search button. And I heard it was Excel Minor Analysis Tool Pack could do the job for us. Uh-oh, doesn't have a lot of good stars, but we'll do that. We're going to click it and install it. Good to see my Google account. Okay, so apparently we can't do it with Google Sheets because it doesn't have verification for some reason. Let's try this. Let's go to Google and let's search ANOVA calculator. One-way ANOVA calculator. We're just doing one way in this course, okay? And these treatments are like your groups. So we just need to copy and paste all this data in for each treatment. So that's not going to work nicely. We got to do each column separately. Maybe I can put it in my Google Sheets. There we go. So if you copy and paste the table, copy and paste the table to Google Sheets, that helps you copy and paste it easier into this first one. But there's different calculators out there too. You could play around with a few other ones that are quicker. Copy and paste this column. Copy and paste this. This will be quicker anyway than trying to get Google Sheets to work. What was their significance level? We can figure this out on our own, but it says a significance level of 5%, so we're going to leave that at 0.05. Click Calculate, and your test statistic is this one right here. Okay? They even give us a p-value too, which we also need. Here's our test statistic of 1.3208 blah 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 blah. 2 decimal places they ask, so I'm going to cut it off here. The p-value from our calculator was 0.28 when we round to the second decimal. That's it. So that calculator is pretty easy to use. Okay, the p-value is high. It's above 0.05. It's 0.28. So that means we should fail to reject the null hypothesis. We can't say that the means are unequal. We can't say that there's at least one mean that's unequal. We can't claim the alternative. We have to stick with the null. That doesn't prove it, okay? That doesn't prove or doesn't provide a lot of evidence that the null is the same. It just means we can't reject that null hypothesis. Based on the evidence, we don't reject the null hypothesis. We don't do any rejecting. Based on the evidence, we should just say there's not, based on the numbers that we got, we should say that there's not enough evidence to make any sort of conclusion. Okay, I think that's it. You know, we can't tell them for sure, but we can say we did the test. We can say that the means are not statistically significantly different.